All right, welcome to my first attempt at a video lesson. And today we're going to be talking about the first section of chapter 10, which is circles and circumference. So we've already talked about what circles are. Circles are the set of all points that are equidistant from a single point called the center. So we have a circle, and that point right there in the middle is the center. We've also talked about that the segment with one endpoint on the center and one endpoint on the circle is called a radius. Let me just turn the marker so it's not as bold. And then a segment with both endpoints on the circle, whose midpoint is the center, is called a diameter. So we've talked about that. That's all review. We've seen that before. There is another type of segment in a circle, and it is one where it has both endpoints on the circle. The diameter is a subset of this, and these are called chords. So a chord is a segment with both endpoints on the circle. A diameter is a chord that passes through the center. A radius is not a chord because it only has one endpoint on the circle. So we have this. That's the basic terminology of a circle. If we have the center of the circle named, say this is point X, the notation we use to name a circle, it is a circle with its center point, and then the name of the point that is the center. That is how we name circles. This is read as circle X. So that's our notation for circles. If two circles are congruent, we use the same congruent symbol. So if two circles are congruent, we still use that symbol. If two circles are congruent, that means all the distances corresponding with them are congruent. So each radius is congruent, all the diameters are congruent, all the corresponding chords are congruent. If two circles are similar, we use that same notation that we use for triangles, but this time all the distances would be proportional to each other. So all the radii would be proportional, all the diameters would be proportional. So that's our basic terminology. Let's start a new slide, if you will. Don't worry, I got plenty of these whiteboards. So sometimes two circles may have a special relationship. One of the most common relationships that we're going to have is called concentric circles. So concentric circles are circles that are not congruent but share the same center. So if you had like a target, these two circles share the same center. All right? So that's what are called concentric circles. They're two different circles with the same center. This is more for practical applications. We're not going to do a ton of this geometrically, but in the real world, this comes up frequently. I am looking out my window and I see my car tires, and I'm just looking at two concentric circles right there. Now, two circles may have other relationships as well. They could intersect. If two circles intersect, there's two ways it can happen. You can have two circles intersect and give you like a Venn diagram type of shape where they have two intersection points. All right? That's pretty much the only way to get two intersection points. I mean, the intersection points could be further over, like you could have this situation. But still really just that type of situation. We've got the 2 points, and then we have what is called the common chord of the two circles. Another way they can intersect is instead of 2 points, they could have one point of intersection. So if they have one point of intersection, they could just be like crazy eyes here. All right? So they have one point of intersection right there. But this smaller circle could not be exterior. It could also be interior. So this smaller circle is interior to the bigger circle and still intersect at a single point. Now we've covered two intersections, one intersection, and if we follow the pattern, that'll bring us to 0 intersections. The obvious case is just two distinct circles, just completely separate from each other. The less obvious case is having a circle inside another circle. These two circles do not intersect, those two circles do not intersect. These two have one intersection, these two have one intersection, and these both have two. Now, there are some measures that have to deal with the circle. We've talked about one of them. We have talked about the circumference of a circle. The circumference of a circle is the distance around a circle. Now, back in ancient times, they were able to physically measure the distance around a circle. They just like take a rope or something like that, wrap it around the circle, and then find that distance by stretching it linearly. And they could also find the diameter. This is how they developed the number pi. The number pi is defined as the circumference of a circle divided by its diameter. Since all circles are similar, this ratio is going to be the same. This ratio will be the same in every single circle. And it's always going to be this number pi. It's approximately 3.14. There's more digits, obviously. It continues on and on forever and ever. But I don't have that much memory on my phone to go through all the digits. Nor do I care to. In this course, unless it specifically asks you to, or the situation does not merit using the number pi, we will leave everything in terms of pi. So, if we simplify that expression to circumference equals pi times the diameter, and the diameter is 2 radii, so the circumference could be 2 pi r. If we have a circle with a radius of 5, the circumference is 2 times 5, which is 10 pi. We would leave it like this. We would leave it like that. This is what I'm expecting in this course. Now, in the real world, you're not going to go out to like a hardware store and just be like, hey, I need 10 pi feet of rope. No, you would be, I need like 31 to 32 feet of rope. Give me 32 just to be on the safe side. Just keep that in mind. So circumference is probably something you already knew. And something else we've already talked about. When we did triangles, we talked about inscribing a triangle in a circle. So this is an inscribed triangle. The triangle is inscribed by the circle. Another way to look at it is you could say it's a circle circumscribing the triangle. Whatever is on the outside is what is circumscribing. Whatever is on the inside is inscribing. And that's how we can tell the difference. All right, so that was our first section of Chapter 10, and I hope you had fun, because I certainly did.